Good morning, good evening, and everything in between. I'm gonna start today's stream with a drawing. I'm gonna try and state clearly what I will be trying to do today. Or hopefully it won't take that long, so what I will start today with. So we're still optimizing the grass, and I think we still have a lot of different optimizations to do. But right now we're deep into improving the visuals of the popping of the grass. So when we get closer to a segment of grass, it tessellates more and we get all these new grass straws, and we want to reduce that popping. What's up, Rogue Bit? Are you ready for some more tries to optimize this? So what we're going to start with today is trying to figure out the logic behind the tessellation that happens on the GPU when we use hull shaders, tessellation shaders, and domain shaders. Because if we have a triangle and we tessellate it like this, and we place grass straws in the center of triangles, I want to figure out when is the first time a new center point appears. So in the initial triangle we have this center point. In the next, so this one we already, or actually this one we already have because we had it here. These three are new ones, and I want to like figure out if there's some logic here we can use to figure out which are new and which are old. What's up, Singoletto Games? And yesterday we tried doing this with the grass shader, and it was somewhat of a mess. So what we're gonna do today is take a step back, create a new shader, implement a simple tessellation, and hopefully we will get a clearer picture from that. So let's just jump right in. So this is how the grass looks right now, not that pretty. So what we're gonna do is we're gonna add a quad in the center. So the good thing with quads is that they only consist of 3 triangles. Let me hide this character as well. Which means that we have like the least amount of information here that we actually need. Let's see, shaders, procedural grass, we have test material. And this is a shader graph. Let's copy this one, I think. Let's go tessellation test. And yeah, we couldn't open this one because we're using a dynamic, but we don't need to do, we can just do this, right? Great. Actually, let's strip this one before we continue. So what do I want to keep here? I want to keep subdivision. We're going to keep all of these, max grass subdivision. Let's keep all of the structs as they were. This is pretty much the only one we want left here, subdivision. Vertex, hull. Yeah, here we're gonna do a lot of things, but let's keep it simple for now. Here we also want to do a lot of things, but we're gonna wait a bit here. I actually want instantiate wind properties. I might want this one, I think. Doesn't really matter, but let's go with 10. Barycentric coordinates, calculate some of these things. Don't care about this. Do I care about this? Don't think so. Tangent to world. This I still want to do. So all of this, everything else I think we can remove. Might want to work with this one a little bit later. What's up, Cypher? How are you doing today? Random seed. I can remove this. I think we can remove this. I don't want Blin Fong. And yeah, let's just return input color here for now. Okay, there we go. A very stripped, an extremely stripped out grass shader. It's not grass anymore. But yeah, we're gonna have a lot of issues here. 169. Yeah, what the fuck? Grass colorize 233. Oh yeah. Output color. Do we have an input color? No, we don't. So let's just go float 1 1 1 1. A little bit worried about the color of this one. Oh well, let's see if we can create a material using this one. Tessellation test material. Okay, we only have subdivision, great. Okay, nice. So subdivision of 1, subdivision of 0. Subdivision of 2, 3, 4, 5. Okay, so something to keep in mind is that we're working with, so when we have a 0 here, it's actually 2 to the power of 0, which is, yeah, this one boggles my mind, but it should be 1, but we're not getting a 1 here. This, maybe we do. Yeah, maybe this is 1. And then we have, so this is 2 to the power of 1, which is 2. 2 to the power of 2, which is 4. And on it goes. AL's good, making a list of PC shit to buy. One new screen, chair, and some other stuff. Gets expensive indeed. But new stuff, nice. That's always nice. Okay, so can we deduce any logic here? Any logic whatsoever? So I want to try by basing the color of the... So instead of just doing color is equal to color, we're gonna send onwards. We're gonna colorize it based on, we're gonna colorize it based on these barycentric coordinates here, because that's actually what I'm the most interested in. So domain shader output, test ID. We do have test ID. Color 1. So let's just do domain shader here. We do output dot, what was it, test ID is equal to float 4 barycentric coordinates 1.0. What's up, Glitch? How are you doing? Hopefully building an office in the new house. I want it to be nice. Oh, love it. Is it the first time you're gonna have a separate room as an office, or? I have my own office in our current apartment, although it's, what is it, 3 times 140. So it's a very small office, but I love it. Okay, let's see what kind of output we get from this. So we set test ID to the barycentric coordinates. And these barycentric coordinates, or this test ID, we're gonna set output color to input.testID, which is a color. And then we use this one. So we just, for the fragment, we just output the input color, basically. Let's see what we get. RGB. So this is barycentric coordinate 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, this is pretty much what I expected. Extremely interested to see what happens if we subdivide this. Would love for this to keep its color. That would be nice. Okay, Cypher, I get it. But yeah, new office. That's exciting stuff. Okay, so let's see what happens if we subdivide this. So right now we're going to go from a subdivision of 1 to a subdivision of 2. And this is what I thought was happening yesterday. So why the fuck didn't my calculations work yesterday? I might have been too quick. But look at this, if we just analyze this a tiny bit. So the barycentric coordinates, they don't change. They don't change. That's good. So this vertex here, like, I want to try this logic as, like, I want to try this as well if this is the case, but this is how I see it. So previously, with the original triangles, we have barycentric coordinate 1, 0, 0 here, 0, 1, 0 here, 0, 0, 1 here, okay? These are still here, but now we have a few more. So for instance, let's take a look at this one. This one is barycentric coordinate 1, 0, 1. This one is 0, 1, 1, and this one is 1, 1, 0. This one is a third, a third, a third. The new subdivision points, the new points we get by doing this are all have the almost all of them have the barycentric coordinates, or one of the barycentric coordinates are 1 divided by the subdivision. Remember, this is 2 to the power of 1, i.e. 2. 1 divided by 2 is 0.5. This new point has 1 coordinate that is... Oh yeah, I said wrong previously. This is not 101, it's 0.50, 0.5. Same with these. So all of these 3 new points have a... One of the coordinates is 1 divided by the subdivision amount. If we go to 2 here, we have the same here. So like this point is actually not new. It's new for this subdivision because of how tessellation works, but we actually had this point in the previous subdivision level as well. See? So this point is left here. Ah, fuck. So this is actually how we thought it was yesterday. So now the issue is, so if we would generate grass based on these triangles, we would generate 1 grass in the middle here of this triangle. If we subdivide again, might be here. Like this middle point does not change, but we get new middle points here. So how can we recognize in this subdivision that this middle point like existed in the previous subdivision as well? That is the problem we want to solve today. 1, 2, 3, 4. Like this middle point will always exist, and we can take, like the middle points don't change, we just add new ones. So this middle point here is new for this subdivision stage. And if we take a look at the next, okay, here. So this middle point still exists here. This barycentric coordinate, yeah. Okay, so the logic previously was, or what we tried to do yesterday was, if a triangle had one term in its barycentric coordinates that were 1 divided by subdivision, then it was an old triangle. But that doesn't hold. That was bad logic. That was a bad assumption to make. But there must be something else we can go on here. The question is what? What's up, Harukanan? And welcome to the Tessellation stream. Yeah, that's a good question. What? You're messing with me, right? I don't see no quad. All I see is triangles, or are triangles. Can we do anything with the middle point? What does the middle point tell us? Please. If we take the middle point here, I don't even know what the barycentric coordinate for that one would be. Like if we calculate the middle point way earlier. Lord Gull, thank you so much for the follow. Well, nice to have another quad enthusiast here on stream. Okay, Harukanan, that explains it. Damn, at first I thought you were just like piling more problems onto me. I implemented my Let's see here. I implement my triangle tessellation algorithm so poorly that it actually generated quads. Yeah, that would suck indeed. But fuck, what is the pattern? What pattern? What information can I go about here? What can I use to my advantage to figure out that this middle point here is new for this subdivision, old for this subdivision? Jesus. Can't you make it pattern as per Triforce? We actually has somewhat of a Triforce pattern. So this triangle turns into a very skewed Triforce, right? But yeah, for the first subdivision we have a little bit of a problem with that. Like, we don't actually have that much, and here you have as well. We don't have that much control. We have some control over the tessellation, but not too much. The tessellation stage is, or actually the tessellation shader is a black box. We can control what domain we work on, how much we should subdivide, what partitioning algorithm we should use, and so on. New middle point, old middle point. New middle point, old middle point. We have to use the subdivision amount is, or let me put it this way, Cypher. Like, me with my current knowledge don't know exactly how to control it. I suppose there exists some tessellation king out there somewhere, some tessellation boss that knows how to do it. Okay, let me put it this way. The barycentric coordinate for, like, we're currently plotting the barycentric coordinate color, and we can see that that one is constant. Like, we don't change that one, which means that the middle point here, the middle point of this triangle, will always have the same barycentric coordinate. That one is constant. So even though the triangle making up this middle point changes, so we go from here, and right now it's being made up of a triangle with barycentric coordinate 1, 0, 0, 1/3, 1/3, 1/3, and 0.5, 0, 0.5, right? So the middle point here is made up of a triangle defined by those barycentric coordinate points. If we switch to 2, it's no longer defined by those barycentric coordinates. You see, this one is new, this one is new, this one is new. So it's now defined by 3 new barycentric coordinates. But the middle point, if we would represent the middle point by barycentric coordinates, those would be the same. So if we can calculate what those are, and then we can maybe see a pattern, a relationship with the subdivision amount, and then we can hopefully figure out if a center point of a triangle was generated in this subdivision or the next one. That's a flawless plan, I think. Good morning, OT. What are you working on? I don't even know anymore, to be honest. But we're working on the grass shader. We're trying to optimize it, and so we're going down into the stack. So highest up we have working on the grass shader, and then we went down a level starting to optimize the grass shader, and then we noticed that we had some popping issues, so then we went down another step to try and reduce the visual popping. And to reduce the visual popping, we need to do some detective work with the tessellation shader. So that's where we're at. The closer we get to a quad, the more it tessellates to generate grass. And we want to figure out at what state or at what value of the subdivision a triangle center was generated. Yeah. I might be insane, but I actually find this extremely fun. Like, it's just at the right amount of frustrating, hard, and fun, I think. It's a little bit of a puzzle. And I don't even know if the answer exists there. I don't even know if it's, like, we might have too little information to actually execute this, but I don't think so. So if I'm trying to deduce, if I'm trying to define what the middle point is, what the barycentric coordinates for this middle point is, I have no idea. But one sec. What can it be? Can it be 0.25? Do we have some tool online? Barycentric coordinates plotter or something. Or can I... I suppose it just annoys me, it's giving you 6. Yeah, it annoys me as well. So, like, going from 0 or 1 subdivision, so no subdivision, to 2, it's not as clean as onwards. So, like, here we get a weird point. So this one is, or is it this one? Yeah, one would have hoped that you got this point, and this point, and generated a Triforce pattern. But from here onwards, we don't have an issue with that. But, like, I thought about this yesterday. I thought this might be the cause of some problems or making it harder for us. But I don't think it really matters that much, if I'm gonna be honest with you. There's probably some reason for it. But okay, so the first thing we need to do is figure out what this coordinate is. Right here. How can I do that? Can you deduce it from the like, can you do barycentric coordinates on barycentric coordinates? So, but let's see here. Let's say that we have a triangle made up of 1, 0, 0, 0, 1, 0, and 0, 0, 1. And then we subdivide this one in a similar fashion as we do here. The centroid of a triangle, x1, x2, x3. Yeah, finding the center is not the hard. So remember, we're working with barycentric coordinates here. So points on this triangle are always like they are represented as in relation to this point, and this point. So when we describe the middle point here, we do it as 1/3 times P1 plus 1/3 times P2 plus 1/3 times P3. where P 1 to 3 can be points in 2 dimension, 3 dimension, or X dimension. It doesn't really work. It doesn't really matter, I mean. So this is barycentric coordinates, and this part is the... So if one would do barycentric coordinates here, it would be... You usually do U, V... What is the last one? I always forget. U, V... I guess it's U, V... whatever. O. So the barycentric coordinate is U, V, O. So for instance, the barycentric coordinate for this point right here is relative to this point, and this point. So it's right in the middle, so it's 1/3 times this point, plus 1/3 times this point, plus 1/3 times this point, okay? Likewise, this one is 0.5 times this point, plus 0 times this point, plus 0.5 times this point, and that's why we get this point. So calculating the middle of the first subdivision, this is easy. So finding this point here is extremely easy using barycentric coordinates. But the next step, this is where my knowledge about barycentric coordinates is missing a piece. Or actually, it's not missing a piece, it's missing the rest. So this is where my knowledge of barycentric coordinates stop. But we can see if we can figure it out. So let's say that we subdivide this, and now we want to find the center point of this triangle. Can we do it by using the original barycentric coordinates? So we make... so for this point we have barycentric coordinates 1, 0, 0. For this one we have 1/3, 1/3, 1/3. And for this one we have 0.5, 0, 0.5. So if we take those 3 points and we do the barycentric coordinates on those, so we do this, like, can you chain barycentric coordinates together? So can I describe this point as a barycentric coordinate of the barycentric coordinate representation of these 3 points? Fuck. That is the big question. So how would that look? So okay, from now on, let's go B11, B12, B13. Oh, actually, B1 is barycentric coordinate. What happens if we do barycentric coordinate 2 multiplied by barycentric coordinate 1 multiplied by or actually it would look something like this: B1x times P1 plus B1y times P2 plus B1z times P3. P1, P2, P3 are this one, and this one. And B1 is barycentric. We get 3 points. So this is 1 point. Okay, so this one represents the calculation of this point, and this point. P1, P2, P3 is P1, P2, P3. So we have 3 barycentric coordinates to describe this point, and this point. So this is basically, let's see, B1 is equal to 1, 0, 0. B2 is equal to 1/3, 1/3, 1/3, and B3 is equal to, so this one, 0.5, 0, 0.5. Okay. And then we want to calculate this point. So we want to do the barycentric coordinates of these 3. So PB1, PB2, PB3. Which leaves us with PB1 is equal to, come on, P1, P2, P3. So PB1 is equal to I guess this is gonna help me. Fuck it. What is it? PB1 1 times. Let's just write it. Is equal to B1x 1 times 1. What's up, Unity Coder? We're doing tessellation, but we're just trying to understand it better. Or I am. 1 times 1. 1 times 0. 1 times 0 plus no. I'm trying to figure out the generation of these barycentric coordinates so that we can figure out at which stage, at what subdivision stage, a new center of a triangle was generated. Put in short. So barycentric coordinates always add up to 1 if it's inside of this triangle. That's why I'm wondering why 0.5 1/3 times 0.5. Yeah, we're gonna get fucked here. I want to figure out what the center of this barycentric coordinate, like the center of this triangle, what is it in barycentric coordinates? And we have this point, and this point. Is there any logic to it? 1/6. In fact, it would probably be quicker to just write a raycasting solution for this one. Mechasonis was up for the 3 points P1. If we want to calculate the center point of this triangle, so it's definitely the center of this point, and this point, right? So that would be just be if this is P1, this is P2, and this is P3. Yeah, if this is P1 epsilon, or what that one is called, and this is P2 epsilon and this P3 epsilon, then yeah, then it's just 1/3, 1/3, 1/3. But I want this point, I want the barycentric coordinates of this point in relation to this one and this one and this one. So I was wondering if you could do barycentric coordinates of barycentric coordinate represented points. Like when we work with tessellation here in the domain shader, we get the barycentric coordinates as a parameter here. These barycentric coordinates are always in relation to this point, and this point. So the original triangle points, not the subdivided ones. So I want the barycentric coordinates for this point related to this triangle. Ooh. Yes. So it's not really, we don't have this line, but so what would this one be? exist a quick way to calculate this one? If you replace P1 by their equivalent, then you get 1/3 times 1 times P1. Yeah, so then we get the points coordinate in world space, right? We don't get, by doing that, we don't get any barycentric coordinates, right? So right now I'm just trying to figure out what is the barycentric coordinate of this one. I don't want the world coordinate of this one. I don't know if I'm misunderstanding you or if you are misunderstanding the goal here. So I'm sorry in advance. The 1/3 in your like P1, P2, P3 are not barycentric coordinates, right? They are just points in the world, okay? So the result of your calculations will be points in the world, right? The result of your calculation won't be a barycentric coordinate, it will be a point in the world. Or am I misunderstanding something? Like what you're doing with your calculations is we have P1, P2, P3, then we use barycentric coordinates to calculate P1 epsilon, P2 epsilon, P3 epsilon, and then we use barycentric coordinate 1/3, 1/3, 1/3 on those 3 points to calculate this point in world space. And I don't want that. I don't care for that. I'm just trying to, right now I want to know what the barycentric coordinate for this point is in relation to these 3 points. I want to see if I can see a pattern or if it can be deduced in some quick way. Right? So seeing, like deducing the barycentric coordinates of this point, this point, this point, this point, this point is easy. Yeah. But like, how do I get this point in barycentric coordinates? So I want to represent this point where my mouse pointer is in barycentric coordinates related to this, this, and this. And what I tried to do here with this weird calculation was, like, can we use, because we know the barycentric coordinates of this point relationship in relation to these 3 points, and we know this point, and this point in barycentric coordinates. Can we use barycentric coordinates on barycentric coordinates to get a result in barycentric coordinates? I don't know. Like, can we step up one level? It's weird. We're out there. Ooh, never heard of it. We'll take a look at it later on. That might be nice. Yemski, good luck, my dude. Thank you, appreciate it. I'm gonna need it. Because the idea is, if we can get this point in barycentric coordinates, then that, like this point, the middle of this triangle and this triangle are gonna have the same barycentric coordinate. We want to get this middle. And like going from world point to barycentric coordinate was it was quite annoying, right? Rogue bit, did I miss anything in the last 35 minutes? No, you did not. Yemski, what does this triangle represent? We're gonna use what we learn here to optimize a grass shader. So this triangle, or these triangles represent, or this quad represents ground, and for each triangle we will generate a blade of grass, a grass blade in the center of each triangle. That's pretty much it. Like this barycentric coordinate here. No. What we're getting in the domain shader is this one. We're getting the barycentric coordinate for this one, and this one. No, fuck, we're getting the coordinates, we're getting the barycentric coordinates always in relation to these 3 points, the one in the end. So we don't have this point, we never will, but we have this one's barycentric, this one's barycentric, and this one's barycentric. So we do a lot of barycentric interpolation here. A lot. If you use distance-based tessellation, wouldn't it automatically handle stills? You get more grass nearby. Yeah. Guys, let me clean up this procedural grass shader once again, and I can show everybody who's new to it what we're currently working on. It will be... it could be nice to just be able to show it quickly. Fuck, do I use this one? I don't think so. Okay, let's see if this works. 331. Right. Is this actually the color of the grass we have? Okay. Oh yeah, we do something here as well. Yeah, that's not good. Okay, let's see if we got this grass up and running. Okay, so this is what we're working with. Thank you, Yemski, for the subscribe. I appreciate it. Yeah, we're gonna do a short video about this one later on. Okay, so we have this grass here. Extremely pretty, not stylized just yet. So we generate this one, and you can see here that we tessellate this plane based on distance from camera. You can see this, right? Very nice optimization. But if we run now, we're gonna see a lot of popping. So you can see the popping here. So you can see when new grass straws are being generated and appearing on screen. Okay, and they are generated because we subdivide this one more time, i.e. we get more triangles, i.e. we get more grass blades. So the idea is to, like when we get closer here and we get new triangles, if we can identify which are the new triangles, we can take the grass straws being generated from that triangle and we can scale them to 0. And then we can also use that, so that scale is based on the distance from camera, which means that when we get closer, we will instantiate a lot of new triangles and a lot of new grass blades, but they will have a scale of 0, and the closer we get, the higher the scale they will have, and eventually 1. So you won't have this popping. I don't know, yeah, it's pretty visible on stream. You won't have like a lot of new grass pop in. It will more grow in, and since it's not popping, it won't be as noticeable. So that is what we're working on. But we don't want to take all of the grass of blades and scale them to 0. We just want to do it with the newly generated ones. And to get those, we need to figure out a way to identify at what state of the subdivision or at what state of the tessellation a triangle was generated. And then we can use that information to hopefully only scale the relevant blades of grass. That's what we're working on. I hope that makes some sense. So if we jump back to our nice little quad here, it's a very interesting problem. If we jump back to our quad here, let's hide this one and this one. So what we're trying to figure out is, so the center of this triangle gets generated when subdivision is 1. So it's roughly here. So this center is not new in subdivision 2, it's new in subdivision 1. This center is new in subdivision 2, but it's not new in subdivision 4. Right? So if the grass blade we spawn on this triangle, we don't want to scale that one to 0 when we subdivide here. We want this one to have a scale of 1 still. We want this grass blade, and this grass blade to have a scale of 0 and scale them upwards. But to be able to do that, we need to identify this, and this point and set it into a relation with the subdivision amount. Simplify my equation, I get this 51. So 51 divided by 81, that's 1 barycentric coordinates. Oh, okay, so you're thinking that those are the barycentric coordinates. What screws me up with that? Let's see, 51 divided by 81. Ooh, you might be onto something. 1 divided by 9, 0.1. Let's see, do they add up to 1 is what I'm trying to get at. What do we have? 51 divided by 81, 0.63. 1 divided by 9, what is it? 11, 0.11. And 15 divided by 54. Looks to be all right. Yeah, roughly 1. So what you're saying is that if those calculations are correct, I appreciate it. Then you're saying that this point has a barycentric coordinate of 51 divided by 81 as an x, 1 divided by 9 as y, and 15 divided by 54. That would fucking rock, and I appreciate it. So those are the barycentric coordinates I like, I want. Does it make any sense? 1/9, what is that? 0.11 times this point. Maybe. 0.63. I would have hoped for better values. So 0.28 times that point and 0.63 times that point. Like, if that is the actual barycentric coordinates, then that sucks for me, for us. 1/3, 1/3, 1/3. So I want to be able to plot let's implement some script so we can do some draw gizmos and stuff like that. Okay, let's see here. What is it? Private void on draw gizmos or something like that. And first of all, let's do public. No. Let's keep it clean, even though it might just be a temporary. Rimurutemest. Sorry about the pronunciation, but thank you for the follow. Serialized field private vector 3 P1 P2 P3 serialized field private vector 3 barycentric coordinates on draw gizmos for each barycentric not in vector 3 position is equal to barycentric coordinates dot x times p1 plus coordinate times x or coordinate x times p1 coordinate y. Wait. I think I'm losing my mind. Yeah, it's like this, right? Barycentric coordinate. Yeah. Plus coordinate dot y times p2 plus coordinate dot z times p3. So then we have the position, and we want to draw something. What is it? Gizmos dot draw sphere. Position, radius, I don't know, 0.1. And let's start with that. What do we have here? We have so let's go with this triangle. Let's try 0.5, 0, minus 0.5, 0.5, 0.5, 0, minus 0.5, 1, 0, 1, 0, 1. Okay, we don't get anything here. So I've done something wrong. Hat, or is it hair? No. Apparel. On draw gizmos. Gizmos. Yo. Is it only during runtime? I thought it was. Yeah, it's not only during runtime. I'm doing something wrong. On draw gizmos, isn't this? I possibly failed to simplify since the sum doesn't make 1 but 1.02. Here are the real values. 1/3. That I like seeing. Thank you so much, by the way, for doing the calculations. It's really appreciated. Fuck, if we have those values instead, I think we can work with that. Yeah, let's try. I want to make this, like, why are these not being drawn? Debug .log. Am I doing something wrong? Probably. It's not my day today. Gizmos are disabled. Dude, let's see. Is it... Where is it you... Oh, thank you. Thank you. There we go. Okay, so that's not entirely correct, but we can work with that one. Thank you. So let's see here. 0.1, 0.01. Tiny, but okay. Let's work with this triangle. So what should it be? Which one is correct? Okay, minus 0.5. 0.5, 0.5 is the correct one. So let's do... Zero 0.5, 0.5, 0.5, minus 0.5, and what should we put this one at? There we go. So minus 0.5. Okay, that's the points, but that's irrelevant. So we're working with this barycentric coordinates, and we have 1, 1, 1, and let's add 1/3, 1/3, 1/3, which gives us this middle point. That's beautiful. So let's try simplified 1/3 plus 1/6 plus 1/9. One third plus 1/6 plus 1/9. And then we have 1 divided by 9. And then we have 1/9 plus 1/6. Okay, yeah, that seems to give us this middle point, which is what is the relationship though? Yeah, it doesn't matter. That point is as good as any. That middle point is as good as any middle point, so it's appreciated. So we can see it's still in the middle of this one. Okay, so now the question is, so this, we get this middle point when we have a subdivision of 1 here, which means that we actually have a subdivision of 2 because we're doing 2 to the power of whatever this one says. So what is the relationship between this, 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 and this here? Ninth. Can we find any such relationship? Like, let's see. Okay, that gives that one. That one gives that point. Can we get this point as well? So there we go. Is that the middle point? Yeah, probably is. 2. Yeah, it is. And if we get to these points, what would that be? Then we're working with this point instead of this point, so it should be just be yeah, it should be, let's take this one, but we flip, what is it? This one and this one, right? Yes, there we go. And then we have we flip this one and this one. There we go. And then the last one we have at, what is it? Is it this one? And then there we go. Beautiful. Okay, so now we have something to work with. If we have a division, let's see here, let's put this into notes. Tessellation test. So if we have, what's up, Meister K? If we have If we have subdivision is equal to 1, i.e. subdivision is actually 2 to the power of 1, which is 2. Any progress? Yes, but tiny progress. We're in the middle of trying to understand this tessellation and the barycentric coordinates and stuff like that. So if we have a subdivision of 1, the new center points are variations of, well, the new center points uses barycentric coordinates, that is variation of 1/3 plus 1/6 plus 1/9, or C2 is equal to 1/9, or C3 is equal to 1 divided by 9 plus 1 divided by 6. So this. So if we have a subdivision of 1, or actually 2, then we get the new center point has barycentric coordinates with these terms. Beautiful. Wolfram alpha. Can we simplify? Let's see how, if this can be simplified to something very nice. I don't know. Should be able to write it like this. And 1/9. 11/18. Okay, so we have C1 is equal to 18, or C2 is equal to 2/18, or C3 is equal to, or is it 2 plus 3, right? So 5. Okay. Also, subdivision is equal to 0. Subdivision is actually to the power of 0, so 1. Then we get center points 1/3, right? Or yes. So then it's just the default one. 0. So then we have the center, this center point. If we have 1, we get these center points. But to actually calculate a pattern, we're gonna have to do this as well. So this one, this one, this one, and so on. I want to see what fractions we're working with there. But before I do that, I just need to take a short break. Be right back. back. I actually find this quite exciting. So let's see. So for this one, we had we want to take 1/3 times this point, and this point. And if we this point we can calculate as okay, so let's see, let's try and get these 3 points. I think this one should be easy, so that one should be, so element 10. Now I need to remember this one. Should be 0.25, no 0.75, 0 and 0.25. Oh, not really. Oh, this is set. Okay. 0.25. There we go. So that's that one. And then we have this one is easy as well. It's just 0.5 and 0.5. This one, however, what are we working with here? This one we had, okay, so 1/3, let's see here, if we do these 3, we have this point, it's between those two, 0 from this one, 0.5 times that one, and 0.5 times that one, 0.5 times 0.5, 0.25, or not really. This point, we only need this and this point, and that's 1/3, 1/3, 1/3. .5, 0.5, 0.5. So we have, what is it, 0.5 times this one plus 0.5 times 1 divided by 3. Right, so it's actually 1/6. Here we have 0.25, or actually 1 divided by 4. 1 divided by 4. And this should be 12, right? So 3, 12. I screwed something up, I think, but whatever. Okay, so 2, 12, 5 twelfths. Is that it? Fuck, I fucked it up. Okay, maybe do it a little bit slower. Yeah, this one helps a bit. Okay. This point, and this point. Oh, I didn't include... Or did I include the original? I did. Oh, we need to take this one into account. That's what I fucked up. So, 2/12, don't we? Plus... I'm doing this way too quick for my own brain. Let's see. If we take Macazonis, thank you for the follow and thank you for the calculations. Appreciate it. This one is halfway between this one and this one. This is 1/3. Fuck, I fucked it up. Okay, let's see. I wanna P1, P2, P3. P1 is equal to, let's call this one, what is it? One, 0, 0. That's the barycentric coordinates. P2 is equal to this one. 1/3, 1/3, 1/3, and P3 is equal to, so this one, half, 0. So this point is just 0.5. Like using these 3 points, it's 0.5 times the P1, 0.5 times P3, and 0 times this one, which means 0.5 plus what is it? 0. 0.5, 0, 0 plus 0.25, 0.25, which is equal to 0.75, 0.25, 0.0. And that's the one we have here. Great. Okay, so these are the calculations we want to use. So if we go to, what is it, this point then it's (0.5 times P2 plus 0.5 times P3. Which means that we have 1 divided by 2 times P2 1/3, 1/3, 1/3, third plus 0.5 times I miss a match. 1 divided by 2, 1 divided by 2, 0. Which means that we have 5/6, right? 3 divided by 6 plus 2 divided by 6, yes. Or? No. No. Damn, I'm stupid. 1/6. So we multiply. Once. Right? Plus 1/4, 1/4, 0. Which is equal to and then we're at 12 again. So 12 plus 3 divided by 12, 3 divided by 12, 0, which is equal to 5/12, 5/12, and beautiful, adds up to 1. So is this what we have? 5 divided by 12, 5 divided by 12, and 2 divided by 12. Fuck yeah. So now, Jesus Christ, now we have this one, and this one. Now we want to figure out this one. 1/3 times this, 1/3 times that, 1/3 times that. So the points we have are mathematics. Let's call this P3 this time around. 0.75, so we have P1 is equal to 3/4, 1/4, 0. P2 is equal to 0.5, 0.5, so 1. I need to... Is this correct? Yeah, I think so. So the middle point here should be so this is just subdivision. Oh, that's subdivision 2, so 4. We're going to clean it up like this. So we're currently trying to calculate 2. Subdivision is actually 2 times 2 is 4. Calculating. So this one, I can't spell for shit today. Calculating. This one is what we're calculating right now. So we want to do 1/3 times 3 divided by 4, 1 divided by 4, 0, plus 1/3 multiplied 0, plus 1/3 multiplied by 5/12, 5/12, and 2/12. So what do we have? We have 3 and 4, that's 12, right? So 3, 12, 1 12th plus 1/6, 1/6, 0 plus 5 divided by 24, 36 and 2 divided by 36. So, which is equal to, what is it, 9, 36, 3, 36, plus 2, 6, 36, right, plus 5, 2, which is equal to 9 plus 6 plus 5, 11, 20, right? And then 9, 14. And okay, 2. 20 plus 14, 34 plus 2, 36. So this adds up to 1, which means that this is our new center point. The question, however, is okay. I want to skip okay, so we only have center points now, right? These center points, then we're going to add a few more center points. So what did we say? 20 divided by 36, 14 divided by 36, and 2 divided by 36. And then, so here's the bad part, I think, or like these will give us, we can 9 times, I think we can, or how many different variations do we have? So like this will probably give us this, and this for sure, I think. Let's see. So let's switch that one and that one. So now we got, okay, we got this one. Oof, I want to do, let's do this. Barycentric calculator, we do barycentric coordinates. Let's keep the name, I want to keep the values. Serialized field, private vector 3. Two, and what is it? Gizmos.color. Gizmos.color is equal to color.blue. Oh no. There we go. So let's move this one there. Now we have a blue one, beautiful. White are middle points 1. Or actually we don't want this one, but whatever. Okay. Ooh. That gives that one. That's not good. Did I screw something up here? Let's see. Oh, yeah, 0.0. So then we get that point. Fuck, we can work with x divided by 18 here as well. That sucks. 11 divided by 18. Is there a pattern here or not? Oops. I don't see it. Maybe barycentric coordinates, the barycentric coordinates we get here aren't the key. That sucks. I'm just trying to see a pattern here. Like, I want to see the mathematical pattern. Like, the blue dots here, these are center points generated when the subdivision is 4. The white ones, some of the white ones, this one, and this one, are center points generated when the subdivision is 1. I want to see a mathematical pattern to distinct between these two. Given only the barycentric coordinates. That's what I'm trying to do. There is some factor that are about 1/2 to the power of subdivision. That's what we thought yesterday, I think. So we're talking about this one, right? And we're talking about this one. Or the least... Yeah. Could this one be the answer? So subdivision 1 has a... its smallest coordinate is... smallest is 1/9. Smallest is 1/18. That's just what we have so far. Could this be the pattern we're looking for? So when I want to check if a... So if I want to check if a triangle, if a patch is being generated this subdivision, then I use barycentric coordinates. I take the barycentric coordinates and I find the smallest coordinate, and if it's equal to this, and compare that one. Is that what I want to do? Or actually, I take the barycentric coordinates, calculate the middle point, and take the smallest of that one. But if this is subdivision 1, and here the smallest is 1/3, I would have hoped that this one would be 1/6. But this one to this one is a little bit of a special case. Yeah, the edges seem to be half at all times, that's true. But yesterday we tried with something like 0.25, 0.5, 12.5. Didn't really work. Do we have... Could it be... Is the pattern... Nah. 3 to the power of s? Or this one. So 3 to the power of 1 is 3. 3 to the power of 2 is equal to 1 divided by 9. But then we have 1 divided by 3 to the power of 3. And that's actually 1 divided by 24. Or 27. Right. Or is it? 3 times 3 times 3. But could it be... Osabu1, thank you so much for the follow. I don't want to do the calculations for the next step here, but I wonder if we can probably, if smallest is 1 divided by 27 or 3 or 36 or something. Let's try and output some tests. We want to test the color here. So let's do float 3 barycentric center is equal to 1/3 float 3 1/3 times, what do we need to do? No. We want to get the middle point given try computing 1 minus, okay. We're gonna try, 1 sec. Barycentric coordinates. One minus 1/2 to the power of s, where subdivision. Is it just the 2 we want to, yeah, times p1 plus 1/2 s multiplied by p3. I have so many notes now, we need to order them in some way. But we don't have any P2 here. Okay. So subdivision, when we say to the power of s, do we mean this subdivision or the actual subdivision? Yeah, rogue bit, that would probably work, but and that's one way to do it. But like the question is, what are the pros and the cons compared to this, because you're definitely going to get different performance and different visuals. S would be the current subdivision, but like the number we're entering here or the actual subdivision, because when we subdivide we actually do 2 to the power of subdivision. So I guess the actual subdivision, so that means that this one is 1, 2, 4, 8, 16 and so on, which would give If it's 1, you get 0.5 times P1 plus 0.5 times P3. If it's 2, you get 0.75 times P1 plus 0.25 times P3. Yeah, this is something similar that we worked with yesterday. So yeah, that's just the line interpolation, right? Between, oh, why do we have an error? Oh yeah. But yeah, there could be something to it. I think we want to do this. Okay, barycentric coordinate, barycentric center. We want to do position 1. Yeah, let's do float 3 position barycentric position 2. And then we just save this one. Or we send it onwards. Output, or do we call it something else? Output dot position barycentric is equal to barycentric coordinates. Like this. Barycentric coordinates. Position barycentric. Okay, let's do it like this. So we output the barycentric coordinate, or we send it onwards to the geometry shader. Here we just do this, restart strip. So let's do input. Let's add float for color here as well. And we do color. So here we just send in white. Okay, great. And then we want to generate some new ones as well. In position world space. Two. Let's just call it 2, because what I want to do here is I just want to output something. Let's see. Actually, we should be able to do this. It should work just like this. The color we send in here, we want to calculate this one. So we want to send in a color here, float 4. We want to calculate it from, so float 3 position barycentric is equal to interpolate barycentric So we get, like, we're in a geometry shader, we're working with triangles, so we're working on triangles and we get 3 points per triangle, so the vertices making up the triangle. So for each of those points has a barycentric coordinates calculated in the domain shader, or sent onwards in the domain shader. And we calculate the barycentric coordinates, like the center of those 3, so what we have been doing manually, which gives us something here. And I want to try, so given 1/9, so what we can do is float compare value is equal to min position barycentric dot x and y, but also between that one and z. So compare value is just the minimum. I'm always forgetting the word for this one, but like the minimum coordinate of making up this one. The minimum term in this float 3. And then we want to do float for color is equal to compare, what did I call it? Float compare, util math, compare float. We want to compare value 1 divided by 9 subdivision 1. And let's just put an error of this. So compare float, if this one is true, so if they are the same, want to return white. Otherwise, black. And then we send in the color here. $272. Position invalid subscript. Okay, position barycentric. Oh, geometry shader output. Yeah, that's not where we want to have it. We want to have it in the domain shader output. Min no matching. Okay. Min. Position barycentric at lines 316. Is it something here? Float compare values equal to 1. Okay. Position barycentric, we calculate this one here. Minimum, oh, I'm pretty sure min HLSL. Yeah. What? Oh, yeah. Ooh, I do like the look of this. I do like it. Oh, how I love this. So white are currently the triangles that are being generated at, or the white triangles are the ones which has a center coordinate that gets generated during a subdivision 1. So we don't have anyone here. At 1 we get these, so all triangles. At this one we only have these, and what the fuck happens then? Then we have these, and that's not correct. Fuck. Close, but not enough. So this one, this one, this one. So we can't do minimum because we're gonna get. Why do we get this one actually? What is the logic behind that? Okay, so one of this center coordinate, one of the center coordinate for this one of the terms is equal to 1 divided by 9. But actually, can we still use this one? So like it might be okay. So when we generate these, what we want to do is we want to look for a value that is the newly generated triangles will have a minimum term of this. Okay, that's okay. And here the newly generated vertex triangles will have a minimum term of 1 divided by 18. But oh, that's not this one or this one. We're close. Or are we? I don't know. I don't know anymore. Feels like I've lost it. This is not the correct way to go about it. We need to take... So this is the same simplification we did yesterday. We need to take more variables into account. But what the fuck? Which ones? Okay, does it have something to do with precision? So the more we subdivide, the bigger the precision we will have. So this is the smallest, or this is the precision we have here. This is the precision we have here. Yeah, that's probably it. So if we could compare precision. Yeah, that's it. But how do we compare precision? So we want to check what is the precision of this barycentric coordinate. If it's equal to this precision, it was generated this. Because I'm pretty fucking sure that if we would continue this one, we would get this. And then, so we would get 2. Well, this is the assumption I'm going with. Right? And this is the precision. So three, 4, 5, 8, 16, 32. So I think this holds true. Like, the barycentric coordinate of a middle point generated during subdivision 1 will have a precision of 1/9. A triangle center point, the barycentric coordinates of a triangle center point for a triangle generated at subdivision 2 will have a precision of 1/18, and so on and so on and so on. So we want to compare precisions basically. I have no idea. Compare float precisions. Yeah, we're probably not going to get much other than this. Typical things like that. Sample. Like, Good question. Let's see. Like if we wanna represent a triangle center that was generated during subdivision is equal to 2, we need to be able to have floats. We need to be able to create floats that are multiples of this one. Does that make any sense? Like the minimum distance between the center and one of the 3 points of a triangle. I like the minimum value a barycentric coordinate can have. Like if we want to be able to represent all triangle origins that were generated during subdivision is equal to 2, we need to be able to build barycentric coordinates as small as this one. Yeah, I'm having a hard time describing it. But this doesn't work. We can't, like we need to, this is too simple. So right now we just take the, fuck me. Oh, whoa. Okay, now I'm getting closer and closer to the thought process we had yesterday. But can't you do... If this is the smallest one, that means that if we take this one and we divide each coordinate here with this one, we should get a whole number, right? So if we do yes. So compare value. We want to calculate this by doing value is is equal to, okay, first of all let's add a float min value is equal to this one this time around. Like 1/3, 1/2 to the power of s. Yes. Yes. But one sec. We'll get to that soon. I think I'm on the same page. Let me just try this. So we hard code min value to 1/9, and this is the minimum value you have when subdivision is 1. Can we do position barycentric dot x divided by min value plus position barycentric dot y divided by min value plus position barycentric dot z divided by min value. What I'm saying here is if this one was generated during this one, fuck, this one, yeah, what I'm saying is if this one triangle was generated during a subdivision with this minimum value, this one should all result in a value with no decimals, right? Like this should be a full value, this one should be a full value, this one should be a full value. And then we have a problem with float precision, of course, but I think it's okay. So then if we do can we do modulus float HLSL? Is it possible? Use ChatGPT instead. Yeah, maybe I should. Oh, 1 sec. Okay, back. Yeah, let's remove that one as well. Where were we? Fuck, is my logic halting here? If we have a minimum, if we divide do I want to do this and then compare value to, then we compare float, compare value 0.0 with this error. That should take the floating point into account. Nah, my thinking is wrong. Fuck. So if this is the smallest value, yeah, it probably works the other way around, right? Yeah, it does. And that's... yeah, so we want to do 1/9. Okay, the result we're getting now is that this is never... that this is never equal to 0, right? We're never getting this one. We're getting it on the first one though, that's sure. That's true. Wait, what? Okay, so the barycentric coordinate is never 1/3. Yeah, okay, so here it works 1/3, 1/3, 1/3. Mean value is 1/3. This one is 1/3. This one is 1/3. This is 1/3. So 0, 0, 0. So why doesn't this work? 1/3 divided by 1/9 gives us no remainder. No, spoil me. Let's fucking go. Could help to know the triangle center position that is the closest to P1, which seems to be... That could help to know the triangle center position that is the closest to P1, which seems to be I have no idea how to use this. That could help to know the triangle center. So, triangle center position that is closest to P1. So the triangle center that is closest to P1. What are we gonna do with this? Okay. Yeah, maybe like let's see. It probably is. I'm not seeing it. Fuck, am I... Compare value, main value. One ninth. Okay, great. Doesn't work here, but if we do... Oh yeah, then we had this problem, yeah. I actually am half wrong in my calculation. I'm listening, I'm all ears. Okay, I need to... Okay, let's see, we're working with the smallest value of this one. So each of the coordinate system is based on this one. This one divided by this one. Can we do... 11 divided by 18. 11 divided by 18. Divided by 1 divided by 9. Oops. 11 divided by 18. .5. 20 divided by 36, 0.5, oops. 1 divided by 18. Oh, why 11 divided by 18 divided by 0.1? Oops. 0.5. Fourteen divided by 36 divided by okay, let's see. 11 divided by 18 divided by 1 divided by 9, 5.5. Two divided by 18 divided by 1 divided by 9. One. Oh yeah, I should have figured that one out. 5 divided by 18 divided by 1 divided by 9. .5. Okay. Twenty divided by 36 divided by 1 divided by 18. Still the old same approach. 10. What the fuck? Maybe. Oh, did I do? 10 divided by 18 should be the same. These are the barycentric coordinates for used by center point of triangles during subdivision 2, i.e. the smallest precision used is 1/18. Should have. Am I tired here? 2.5. Yeah, I am. And divided by 18 divided by. I'm losing it. That should be 10 divided by 18 divided by 1 divided by 9, 5. We can probably not work with this one like I thought we could. That's for sure. Like the only pattern we have seen so far when it comes to barycentric coordinates, the center, like the only pattern we see of the center of the triangles represented by barycentric coordinates is the smallest amount that needs, like we don't need anything smaller than. Actually, that's not even true. I'm off. I'm way off. Like, this is not true because we can't represent this one by 9th. But, oh well, it's the smallest it is. Wait one sec, 19? One third. Why are we getting a... I have a way to compute it, but it necessitates a for loop that is too complex for me. That is why I will keep working on that to get the full equation. Actually, is it? It felt like we were so close, and now it's miles away again. We have the middle point barycentric coordinates. And the more we subdivide, the more precision we need to represent those barycentric coordinates. So we should be able to do something with precision. We should be able to get some nice information from precision, right? Like representing this coordinate as a barycentric needs less precision than representing this center as barycentric coordinates. Or like this one is Why am I not seeing it? There has to be something. Yesterday, I think the assumption was it's pretty much the same assumption as today, but yesterday we worked on, instead of working with the center point and the barycentric coordinates of those, we worked with this one. Like this one, and this one. There's really no difference though when it comes down to it. I think this one is a better option to work with. But still, what the fuck? Like, if I think about this, let's do. If we would have just done this with classical UV coordinates instead, so we have a quad, no triangle, and we want to calculate center points. I guess center point, center point, center point, center point. So here we have a subdivision of, fuck it, let's do 1. If we subdivide it once more, they get removed. But if we subdivide it 2 times like this, these are old. They are at 0. 0.5, right? 0.20, 0.25, 0.125. So if we have this precision, we just check every point that is some uneven multiplication of. So this is a 0.1225, 0.5. Mechasonis, I'm listening. I'm all ears, man. I'm losing my mind. Cypher, we shipped it yet? No. Mechasonis, if you got it, damn, dude. Because I'm losing my mind. So, and this is 0.5. And this is 0.625. Fuck is this? No. 0.75, 0.875. This is the precision we have. So this is a 1 times that precision. This is 4 times that precision. What is this then? 1, 2, 3. Or is this? No. 1, 0, 1, 2, 3. Fuck, I'm losing my mind. 1, 2. 4 times. Mechasonis, I'm waiting. Like it should be, like one should be able to get the information here from precision. But I screwed it up. Okay, let's take a look at this value. So what are you saying this value is? Let's see. Yes, indeed it is. So what is this? What are we seeing here? Okay, but the resulting point from this, what is that point? I don't understand. The center of the closest triangle's center of P1 for S subdivision. The center of the closest triangle's center. How is that helping? I'm lost. Because your precision is the minimum between x, y, z in barycentric coordinates at S subdivision. Okay. I'm gonna have to sit down and think about this. Try and understand it. Yeah, this is insane. Let's see, let's just add some notes here. Let's see if we can make any sense out of that. Like, it's the precision you would need. So if you want to represent this point in relation to this square, you need a precision of 0.25. So this is the smallest number you need to represent this point relative to its corners. Like in UV coordinates, it's 0.25. But if we subdivide it even more, like this, and we want to represent, we want to represent this point, then we need even smaller representation. We can't get to this point with this big of a precision, right? We need 0.125. right? So then we need a even more precision. And then if we subdivide it again, then we can't get to this point using this big of a precision. We need to subdivide it even more. And that's the precision. And this holds true for this as well. So we need more precision to represent this point than we need to do this point. And if we can figure out a way in code to calculate how much precision is needed to represent one of these points, then we know when it was generated. Like, that's one way to do it. Probably a bad way. Can you make the same explanation for triangle just to make it explicit? Yeah. So here we have it. Oh, it feels like we're close. But it also feels like we've been close for a while. Pretty much at the exact same place we were yesterday, but with a bit more understanding, I would say, of the barycentric coordinate tessellation. Okay, let me put it this way. But I don't know if this helps us. But like in this case, every term of a barycentric coordinate is a multiple of this one. A full. So like it. But that's not true for this one. I had high hopes that we would be able to get to the bottom of this stream. Doesn't look to be the case though. But okay, so we have the barycentric, the center given in barycentric coordinates for each triangle. I think I have the 3 coordinates to just search the minimum. I'm all ears. I'm all ears. Math indeed, Cooler SK. Frustrating math. Did you at least feel like you made substantial progress? Good question. I try to be an optimistic dude, so yes, like I've learned some new things today. That's progress, right? I'm a tiny teeny bit better than I was yesterday. This solution is a tiny teeny bit closer to resolvement. I'm pretty sure it would improve it would definitely improve the popping, for sure. Okay, Megazone is. So now we have this P3, P2, P1. Yeah, that's true, Rogue Bit. We have a couple of fallback. We have a couple of fallbacks we can do. It's okay. Okay, Mechasonis. So this one gives a point. And that point, what is that point? Yeah. Actually, this one. I don't like that point you have calculated, Mechasonis. What is that point? Like, how am I gonna use it? I'm not entirely sure I understand. And then we do this. No, I forgot. Whoa, 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 whoa. Yeah, unfortunately I have to quit for today, but okay, so your equation is the most upper red dot, so this one. I have it saved. I have the equation saved. Do I have the latest one? Yes. And I'm gonna continue this tomorrow. Hopefully arrive at a fucking solution tomorrow. But whoa! Yeah. Need some way. We need some way to distinct between the red, blue, and green. Red, blue, and green points. Harukanen, not for me. I would have taken a day off if I could have solved this problem, but no, I'm gonna grind. I'm gonna find this solution tomorrow. But yeah, unfortunately, would love to continue this today, but I can't. I have to run. But thank you so much for watching, everybody. As always, have a great rest of the day. Hopefully I will see some of you tomorrow. Peace out.